The physics of Santa's sleigh. Can it really deliver billions of gifts? Hey everyone, and welcome back to the channel. It's the most wonderful time of the year, filled with carols, eggnog, and, of course, the age-old question that has plagued scientists and children alike for centuries. How on earth does Santa do it? We're not talking about magic today, folks. Oh no. Today, we're putting on our lab coats, dusting off our textbooks, and diving deep into the physics of Santa's epic Christmas Eve journey. Can one man, one sleigh, and a team of reindeer really deliver billions of gifts around the world in a single night? The numbers are astronomical, the challenges seem insurmountable. But hey, that's what science is for. We're going to break down the speed, the weight, the energy, and even the reindeer power. By the end of this video, you'll either be a true believer in the impossible or you'll have a newfound respect for the laws of physics. Let's get started. The speed problem, relativistic Santa. All right, let's tackle the biggest hurdle first. Speed. Santa has roughly 31 to 32 hours, thanks to time zones and Earth's rotation. But he still needs to visit every good boy and girl. How many are we talking about? Current global population is around 8 billion. Let's conservatively say 2 billion children and maybe 500 million households. If we average, say, 3.5 children per household in a given region, that's still roughly 200 million stops. Now factor in the surface area of Earth, 510 million square kilometers. If those 200 million homes are evenly distributed, that's a lot of ground to cover. To hit 200 million homes in 31 hours, Santa would need to make about 1,786 stops per second. That's almost 3,000 miles per second, or about 0.5% the speed of light. This kind of speed introduces some wild physics. At that velocity, the air resistance would be so intense, the sleigh would instantly vaporize. We're talking temperatures hotter than the surface of the sun. Santa, the reindeer, and all those gifts would be reduced to plasma in milliseconds. And then there's the G-forces. Accelerating and decelerating 1,786 times a second? Forget gifts. Santa would be smeared across the inside of the sleigh like jam. It would take unfathomable amounts of energy just to move through the air, let alone stop and start. But wait, some might argue for relativistic physics. Could Santa be utilizing something like time dilation? If he were moving close to the speed of light, time would pass slower for him than for us. So his 31 hours could feel like mere minutes to him while weeks pass for us. This would give him more perceived time for his deliveries. However, the energy required to even approach relativistic speeds is mind-boggling, and the practicalities of entering and exiting such a state 200 million times, well, that's a challenge even Einstein might scratch his head at. The weight problem. Impossible payload. Next up, let's talk about the payload. What is Santa carrying? Billions of gifts. Let's make some conservative estimates. If we assume an average gift weighs just 1 kilogram, about 2.2 pounds, think a board game, a small toy, a book, and there are 2 billion children receiving one gift each. That's 2 billion kilograms of presents. That's 2 million metric tons. To put that into perspective, that's roughly the weight of 2 Great Pyramids of Giza, or over 1,000 fully loaded cruise ships. This single sleigh would be the heaviest moving object on Earth by a factor of hundreds. How does a sleigh, even a magically enhanced one, carry that much weight? The structural integrity alone would be a nightmare. No known material could withstand that kind of stress without immediately collapsing under its own gravitational pull. And then there's the energy required for lift. To get something that heavy off the ground and keep it airborne, you'd need an insane amount of thrust. Forget 8 tiny reindeer, you'd need millions of rocket engines firing constantly. Now, the magic argument often brings up ideas like Santa's sack being a bag of holding from fantasy, infinitely large on the inside. Or perhaps the gifts aren't actually in the sleigh until the moment of delivery, maybe being teleported or even assembled on the location using advanced nanotechnology. While fun to imagine, these concepts push beyond conventional physics into pure speculation. Reindeer power, mythical mechanics. So we have an impossible weight and an impossible speed. Now, who's providing the propulsion for this impossible mission? The reindeer, of course. Dasher, Dancer, Prancer, Vixen, and Rudolph with his glowing nose. Let's assume a typical reindeer can generate, say, zero point 0.7 horsepower. 8 reindeer, that's about 5.6 horsepower. Not even enough to power a small car, let alone a sleigh weighing 2 million metric tons at near light speeds. To overcome the inertia, the air resistance, and provide the necessary lift, you'd need literally trillions of horsepower. We're talking about propulsion systems that don't exist in our current understanding of physics. We'd need something like anti-gravity technology, perhaps manipulating gravitational fields or some form of exotic matter to negate mass. And Rudolph's nose, while charming, a simple bioluminescent glow isn't going to cut through fog at Mach 1000. For it to be a useful navigational aid at those speeds, it would need to project an incredibly powerful, focused beam, perhaps like a plasma torch or a hyper-advanced laser. If we're really stretching, maybe the reindeer aren't pulling the sleigh in the traditional sense at all. Perhaps they're merely the navigators, and the sleigh itself is powered by some advanced hidden engine, a cold fusion reactor, a miniature black hole, or even a localized wormhole generator. Now that would explain how they get around so fast. The chimney problem and delivery mechanics. All right, let's say Santa somehow arrives at 200 million homes. Now he has to deliver the gifts. This brings up two classic problems: the chimney and the speed of placement. First, the chimney. How does Santa, a man of generous proportions, fit down millions of chimneys, many of which are impossibly narrow or non existent in modern homes? A classic theory is that he somehow compresses his molecules, or perhaps the sleigh has a transporter beam, like in Star Trek, instantly dematerializing him and the gifts. If he's compressing his molecules, that would require incredible amounts of energy and control. Think about how much force it takes to compress anything. And how does he then decompress without exploding into the living room? Then there's the speed of delivery. Even if he can instantly appear in the living room, he still has to place gifts under the tree and eat cookies. If he's making 1,786 stops per second, he has about 0.00056 seconds per house. That's not enough time to even think about a cookie, let alone eat one, unpack a present, and place it under a tree. So, from a purely scientific Newtonian perspective, the entire operation is a colossal, fundamental violation of pretty much every law of physics we know. The speed, the weight, the energy, the delivery mechanics. It all screams impossible. So, does this mean Santa doesn't exist? That Christmas is a lie? Well, not so fast. Science, while explaining much, also continuously pushes the boundaries of what we understand. Maybe Santa is utilizing an advanced form of physics that we simply haven't discovered yet. Maybe he's tapping into dark matter for propulsion or quantum entanglement to instantly transport gifts. What if his sleigh is a localized wormhole generator, allowing him to pop in and out of space-time at will? Maybe the reindeer aren't biological creatures at all, but highly advanced biomechanical drones or energy conduits. And Rudolph's nose, a compact fusion reactor providing power and guidance. The beauty of this thought experiment is that it shows us just how incredible the magic of Christmas really is. For Santa to accomplish his feat, he would need to be operating at the very cutting edge or far beyond our current scientific understanding. He'd be a master of relativity, quantum mechanics, and propulsion systems that would make Elon Musk blush. Ultimately, the physics tells us that by all conventional measures, it should be impossible. And yet, every Christmas morning, those gifts are there. Which brings us to the most powerful force of all, the power of belief and call to action. The magic of Santa, when viewed through a scientific lens, reveals the immense power of human ingenuity, imagination,
and perhaps the extraordinary. It shows us that sometimes the most profound answers aren't in the equations, but in the belief itself. Whether you believe in the magic or the undiscovered physics, the story of Santa Claus reminds us of the joy of giving, the wonder of the season, and the incredible things that happen when we dare to imagine the impossible. So, what do you think? Is Santa a master of advanced physics? Or is it pure, unadulterated Christmas magic? Let me know your theories in the comments below. If you enjoyed this journey into the physics of festive delivery, please hit that like button, subscribe for more scientific adventures, and share this video with someone who needs a little Christmas cheer and maybe a little physics lesson. Merry Christmas, Happy Holidays, and I'll see you in the next video.